Hello, you're welcome to yet another lesson. This time around, we want to examine the derivation of quadratic formulas. Remember, in our previous videos, we established that quadratic equations are equations that are in the form ax squared plus bx plus c equal 0. So any equation in this form can be classified as a quadratic equation. Now, we realized that some of the equations become factorable. Others do not easily get factorable. In view of that, mathematicians devised certain strategies that we could use to solve such equations. Among them include the completing square method and the Poisson-Law method. Under the completing square method, we also have what we call the quadratic formula. Particularly, many people refer to it as the general formula or the almighty formula. We are therefore about to look in this video at how it can be derived. Remember that in using the completing square approach, this equation that we have here should have 1 as the coefficient of x squared. So the first thing we can do is divide each term of the equation by a. So that is, we divide each term of the equation by a. Now should we do that, we realize that we are going to have x squared standing alone. If you agree with me, x squared standing alone. We then move to bx out of a. bx out of a. We equally have the next term being c out of a. The other side of the equation could or is also written as 0 out of a. Now, the next thing we can do at this point is to try to move this constant term of the equation to the other side. But before that, remember that since the numerator of this fraction is 0, the answer here is going to be 0, right? Agreeing with me on that, we therefore move this constant term to the other side of the equation. In other words, we try to move it from here by taking out the additive inverse of the constant term from both sides of the equation. In simple terms, we mean x squared is going to be present, equally, we will still have our equation bx out of a being present again. Now this time around, since we are adding the additive inverse of this constant term c out of a to both sides of the equation, it is going to take this term out of this area and send it to the other side of the equation, where we are going to have the negative of the constant term being placed at the other end of the equation. Thus, we're going to have something like this, right? At this point, the next thing we can do is to, if you remember, add half of the coefficient of the x to the square of half of the coefficient of x to both sides of the equation. Again, we add half of the coefficient of this x to both sides of the equation. So our x is still present, that is, we have x squared plus this same term coming back what do? We add, so plus half the square of the coefficient of this x. So the question is, what will be half? Right, so like we said, so b out of 2a all squared added to the left side of the equation and to the right side of the equation. Remember, the constant term is also a part of the right side of the equation, so let's not forget it, right? At this point, remember, this part of the equation becomes a square, like the square of a certain term, a certain binomial, and the binomial can be obtained by taking this form. That is x pardon me, so it will be appropriate for me to do it this way. So we have x plus, because we have the um the half of the coefficient of x being plus a positive one, so plus b over 2a, so plus b over 2a, so b over 2a all squared, and that should be equal to this right part of the equation. Good. The next thing we can do is to make things a bit more clear and simple. How can we do that? Let's see. Right, so this part of the equation will still be present. Good. And then the right side of the equation will be evaluated.